In this video, I'm going to discuss trend seasonality analysis, how to perform trend seasonality analysis using the New York City chickenpox data from 1931 to 1972. So let me first download this file. This is how the file looks like. These are number of chickenpox cases from 1931 all the way to 1972, broken down month by month. So first, to make this a clean time series data, what we have to do is put this all into a single time series. With this data, since I know that the continuity goes from 1931 January all the way to December, and then this row and so on. So let me quickly transform this data, Control C, maybe paste it as a transpose, paste it special, transpose, all right, there we go. This is 1931 data, 1932 data, and so on. So for now, I'm just going to copy paste all these values and make it a single sequence. This is how the data looks like upon cleaning. This is the first year, second year, and so on. So now what we have is actually a clean time series data. So to perform time series analysis, I'm going to copy this and paste it into a new Google Doc. And let me actually start a few columns down because I would like to create my curves all the way at the top. So I can create a spark line using my data all the way here. And there we go. I can see my spark line. So in time series decomposition, the first thing is to obtain the trend. That is, we want to smooth the data using a moving average. So in this case, we know that since this is yearly data broken into months, the moving average period or the seasonal period for our data is 12 months. I could start by saying average and then next 12 numbers, but this would be incorrect. We shouldn't do this because this is not a moving average. Instead, what we can actually do is calculate go 1, 2, 3, 4, 5, 6, and then for this average of these 12 numbers. So this would be an appropriate moving average. I'm going to autofill as well. So what about the values here? One thing that we can do is simply copy this average and paste it a few times here. That's one reasonable approach. Another is to just duplicate this value 6 times over here and calculate the average. In our case, since I know that we have lots of data points, this is not going to impact our overall results a whole lot. So I'm just going to leave it as it is. Also, if I scroll down, the last 6 numbers, so I'm going to get rid of these as well. All right, so I have my data, and now I'm going to also plot or print the overall trend. So this should be B, C. Okay, so this will be it. So we have the data and then the trend. The next step is to obtain, if we go back to the document, obtain detrended series. So to calculate detrended series, in our case, since this is additive model, we want to do time series minus the trend. So this would be data minus the trend. Intro autofill. Okay, so let's plot the detrended data as well. Detrended data as well. So this would be D. Okay, there we go. So this is detrended data. Once again, let me color it separate. Okay, so here we go. We have the detrended data as well. So now the next step in the time series decomposition analysis is to obtain seasonality. So to obtain seasonality, what we need to do is first obtain average values for our period and then copy repeat values for the entire series. In other words, we need to find the average for January, February, March, all the way to December, and then copy over that data, basically repeat it. So the average of all January would be average, and then okay, one thing that's very important about seasonality is that it should be calculated from the Detrending series, not from the original series. We're going to go back, and so this is what we're going to use to calculate monthly averages. So here it will be average of, so this, since this is for January, whatever value is here, whatever value, comma, whatever value is here, whatever value is not here, here, and so on. But we need to somehow automate this. So what I'm going to do is use something called average if column AA, if it is equal to 1, that is my first month. If this is equal to 1 for all Januaries, I want the average of all the detrended data, DD. So if I do this, what I have here is, I'm not going to autofill here. So this is average detrended values for the month of January. So I could pull down. Now this will be, if I make it equals 2, then this will be for February and so on. So I'm going to make it slightly more automatic. Go back and fix it. Concatenate equals to, and then the same month value. And then now I can scroll. So this is for January. So then if I go all the way to end, so now this, what I have here is the, for all 12 months. So this is going to be equal to A26, give me for all the Decembers and so on. So here we go. So now we have the monthly averages. Okay, so now the next thing to do is to calculate seasonality. Simply repeat the same values. Paste is special. Let me do values. We basically repeat this thing over to the end. Okay, we should be almost done now. All right, so I'm going to skip these last values. There we go. We have the seasonality here. Let me also count the total number of items. Okay, so we have total, how many data points do we have? Okay, 498 data points total. All right, so the next thing to do is to plot the seasonality. Let me actually copy this and paste it. G, okay, from here to here, this is how my seasonality looks like. Let me color this differently, maybe use the color blue. Okay, so we have seasonality. Now the next thing we need is the noise. So we have the original data, trend, detrended data, and this is seasonality. Now the next thing we need is the noise, the remaining data. So in additive model, we can calculate noise by doing time series minus trend minus seasonal. So this would be original data minus trend minus monthly, or actually here, monthly seasonality. Okay, there we go. Yes, we can autofill, and this would be the noise. Okay, so here's our noise, and since we actually don't have trend, I'm going to get rid of these values for the noise. Also maybe remove the bottom 6 values. This will be our noise, and this is the column H. So here's how our noise looks like. Notice that there's a peak in the middle here. The original data also has a peak, but it looks like this peak is actually not a part of seasonality. There's also a peak here. This is also not a part of seasonality. So this is just to show the overall trend. It's easier using spark lines, but ideally for like your final production, what you would do is actually insert line diagrams. So you could actually do maybe for, let's say, the original data, you would do data, and then maybe we can select the data point column and then insert chart. And yes, we have a line chart, which is good. That's what we want. And we should, so this would be the y-axis would be the actual data point, and x-axis shows the number of the overall time, like from years, each month, and so on. So ideally for production, you would plot these, like not just a spark line, because some of the limitations of a spark line is I don't know how long the time series is. I don't have the values for the y-axis and so on. So for quick analysis, initial analysis, spark lines are good, but then for the final production, say for example submissions and reports and so on, you would actually have a valid, a really good x-axis and y-axis with all the values as well.